Yo, welcome. Scientific notation. Shout out to all the parents out there. Thank you for coming last night if you came. If you didn't, it's okay. We're here again, right? You and I, so it's all good. A couple of ways that we can get scientific notation done with. The first way is kind of the real way, right? It's not really a fake way, but there's the real way. And the real way is use the laws of exponents and work it out that way. The kind of a cheat way is, well, we'll get there. 4 problems for you. Multiplication, okay? The real way is this. Separate the numbers in the front, right, of the times 10 to the whatever, and multiply them, right? So I've got 6 times 5.5, right? So that's going to give me 33. So let's just put that to the side for now. Then I've got something that we've been working on for a couple days now. So it's 10 to the third times 10 to the 0, right? So we have the same base. Use the laws of exponents to put those together. So I would add those normally. So this is now going to say 33 times 10 to the third, right? Because 3 plus 0 is 3. Now, I can't keep that in scientific notation because that's not a number between 1 and 10. Remember, it's got to be between 1 and 10. So because it's not, we need to change this because this is not right. So what I'm going to do is I'm going to move the decimal place over. Ooh, that's terrible. I'm going to move this imaginary decimal place over one more time to the left. Because of that, this number is going to increase by 1. So now I've got this 3.3 times 10 to the fourth. That's going to be my answer. So if I'm going to increase this decimal has to go to the left. So if I were to move the decimal to the right, which we'll see in a minute, I would actually decrease this number by 1. I know that's going to be confusing, but over time you're going to see that's a little bit better. This is my answer here. Okay. Now for the cheat way, right? So the kind of fake way to do this. Take this individual term or this number and take it out of scientific notation. So for instance, 6 times 10 to the third power. And wow, this board is like getting worse. Well, if I have 6 here and it's to the third power, it means I got to move the decimal place to the right 3 times. That number is 6,000. This number is 5.5 times 10 to the 0, but we know what anything to the 0 is, and that's 1. So it's 5.5 times 1. So this becomes something a little bit more manageable. It's 6,000 times 5.5. That's kind of a little easier, I think. But it's still kind of a cheat, right? So that becomes 33,000. Now I can put it back into scientific notation because that's not the answer. Imaginary decimal place, 1, 2, 3, 4. So we've got 3.3 times 10 to the fourth, exactly what we had the first time. Okay, so we'll do it the real way, and then we'll do it this kind of real but not real way. Okay, still multiplication. Multiply 3.8 times 3.5, and that's going to give me 13.3. I got times 10 to the negative third, times 10 to the first. Remember, multiplying, we're going to add those numbers together. So this is going to be 13.3 times 10 to the negative second power. Problem. Can't see me, but you can see my arm. Okay. I got to move that. All right, that's not going to work for me. So this is now going to become, because I got to move it to the left once. And remember, left means I'm increasing that by 1. Increasing. 1.33 times 10 to the negative first power. Remember, I'm increasing it by 1, not decreasing it. So that's going to be my final answer. And if you want to go ahead and try it the other way, some of you might like it easier. I don't know. It's up to you. Moving on. Division. Remember, same rules for division. Don't get freaked out. It's really actually just kind of opposite of what we've been doing. I'm going to divide these numbers first. 1.88 divided by 8.7. Okay, when I get that, I get 0.216, and I'm rounding this 1 up because that's really a 0. I've got times 10 to the negative first divided by 10 to the negative second. Remember the division rule, the quotient rule, right? When I'm dividing numbers with the same base here, I'm subtracting those numbers. Now be super careful with this. It's negative 1 and negative 2. But what it says to do is negative 1 minus negative 2. The extra minus sign you have to put in there. It's not built in. It's not negative 1 minus 2. That's totally different. It's negative 1 minus negative 2. So change, right? Whoa, that's terrible. This is going to become just positive 1. So 0.2161 times 10 to the first power. Now, problem. That's not between 1 and 10. Now I have to make it between 1 and 10. So because now I'm moving the decimal one place to the right, that's going to decrease by 1. So this now is 2.161 times 10 to the 0 power. Okay, that's my final answer. And again, if you wanted to put the numbers into regular terms, so out of scientific notation, then divide them, just remember to put them back into scientific notation, because that's what we're talking about, scientific notation. Okay, last one here. Go ahead and try it if you want. Pause me. I do that a lot. I should stop doing that because you're probably getting bored of it. Let's work it out. So I'm going to give you the answer. The answer is 3.518, that's a terrible 5, times 10 to the negative second power. Be careful because, actually, you know what, that one's easy. There's no tricks with that one because when you divide those numbers, you get that evenly. All right? Scientific notation, not too bad. Better than exponents, but not as great as like other cool stuff like functions. So, I'm out.